Is the mic on? Great. Okay, so as Slava said, I'm going to do a small introduction of Dart. So this is really the basic intro, nothing required in terms of what you know about Dart. So just a small presentation. I'm Florian Loitsch. I've been working at Google for more than 4 years now. Before I joined Google, I worked mostly on scheme-related projects, so scheme to JavaScript, JavaScript to scheme compilers. That one of them was my thesis. And then I worked on V8 a little bit, and then I was fortunate enough to be part of the team that actually designed and built the first draft and design of Dart. So why Dart? So the web is fantastic. It allows you to create small apps easily. It's you don't need to install. You can incrementally develop. You just press F5 and it just runs again. You don't need to compile. And the browsers, they just get better and better. There's a friendly competition among the major browser vendors, and that actually makes a difference. If you look at the pages from 1998 to 2008, so in this case BBC, but you could have taken Gmail or any other big app, they changed quite a lot. And more importantly, the browsers themselves changed. They became much faster. So when Chrome entered basically in 2008, the JavaScript speeds just became much faster. So this is the Chrome DB8 benchmark suite, Octane now, and this allows applications that are much better and bigger now. However, there are still some issues with the web. So in our opinion, the productivity, scalability, and performance of web apps is just not there yet. In my opinion, it's also that you don't see really. You're surprised when you see big applications in Dart, in JavaScript, in the web. There are some nice out there. There are always some examples that show that you can do it, but most of the time you rather pick another language that is more that you feel is more suited for big applications. And if we don't keep innovating the web browser platform, you kind of lose to native apps. So most of the time you now see small apps written for Android instead of just having a nice web application. And we try to fix that. And Dart is basically our proposal to fix it. And here are some small, so Dart in a nutshell, some properties of Dart. So it's object-oriented and unsurprising, and I will talk about this unsurprising later. It's class-based, single inheritance, a little bit like Java. And it has a familiar syntax with proper lexical scoping. So familiar syntax means curly braces and semicolons. That's just the way it is. And proper lexical scoping, that's probably just for those who know JavaScript. That means that you actually can put things, embed them, and they will shadow the correct way and things like that. It also has an optional static types system. That's probably newer to some, and I will start by giving a small presentation in the Dart editor what that means. So we will create a new application. So this is the Dart editor. This is the editor that comes with Dart that is maintained by us. And, well, let's just run it right away. So simple hello world. No. Yes. So we can change that. Let's create a small class. No. My class. And we can instantiate it. And if we print it, well, it's not going to print something interesting, but when we run it, it just tells us an instance of point. So we still have things to do to get to a real point. Usually a point has some fields. Let's put some fields in there. Now let's start with var x, y, and so far. And the toString methods, that is toString. Here's the first thing that you probably don't know is the arrow for shorthand for a small function, and we call it a point with $x, $y. So this will string interpolate x and y into the string. So we'll put x and y into the string. So if we print now, if we run this again, well, so far we haven't initialized x and y, so it's just set to null, but we're on a good track. So now let's add a constructor to initialize x and y. So this will just put the arguments that the constructor gets directly into the fields. This is a shorthand notation for initializing the fields in the body. And as you can notice, immediately you get a warning here that tells you that the argument's missing. And so let's put, I don't know, let's put 1 and 1 here. No, not dot, comma, 1. And if we run it now, we actually get the right point. So I said before that this is an optionally typed system. That means that you don't need to write types, and so far I haven't written any types, type annotations at least, but you can. And in this case, we actually want to. Let's say we want these to be nums. We actually return a string here, so might as well write it. And here we can, if we want to, also say this is going to be a point. But it's probably not really necessary since there is a new point afterwards. There's not. It's more for documentation than giving you anything else. So since there's a new point after the equals, adding a point in front of the first one is not really helping. But we can do it. So let's do another one here where we actually write it and create an origin point. And let's now implement the distance2 function. So distance2 takes another point, and we have a delta x that is minus x and delta y. So what's interesting to notice here is that if I write other dot, it doesn't give me lots of completions. I mean, it gives me the 4 completions that every object has, but it doesn't give me the y. Now, if I, however, actually use the type annotations, and I try this again, it will give me the y. So this is one of the reasons why you usually like to write type annotations to help you in the development. It's easier to read for newcomers. They see what the argument should be or what the return value is. And it also helps you in the tools, in this particular case, the editor. So you will have more completions. You will have better refactoring tools. You get driven to add type annotation, especially on interfaces and signatures. And then return t of x plus y. So SQRT is missing here. That's because it lives in a different library. This seems to be modules and different modules seems pretty much common in almost every language, but not in JavaScript. So this is another thing where creating bigger apps just makes it easier and nicer in JavaScript, in the web development. That said, new ECMAScript I think has modules too, so they add things too. Let's say that this is a none, and now let's test it. Origin distance2 p. And run it, and we get the distance. So that's the small introduction. There are lots of other things in Dart that I haven't shown, like mixins or named constructors or all kinds of different things. But let's go back to the slides and continue there. So another thing that's important is that we wanted to make Dart unsurprising. So for one, now that Dart 1 is stable, we hope that people can actually work with it and have an unsurprising behavior. What I mean with unsurprising behavior is, let's look back at, so we want to go from that to that. That's Casper's slide. So what we mean is if you look at JavaScript and you create a new point, it's not clear from looking at the sources itself when there's a class, when there are fields. It kind of is mangled in the whole execution. And in fact, you build classes, hidden classes, dynamically. You don't have them statically there. So in this case, you have a function, a normal function point, and just by the way you use it, it becomes a class. In this case, this.x assigns, if you use point as as a function, as a constructor, it will become a constructor. Yes. So the problem is that sometimes you can create different classes or hidden classes depending on what you do in your constructor. So sometimes you use object-defined property because then you can finalize, you can make them immutable. If you don't have this property, then you have to fall back to the old way of defining fields. In short, it means that finding out how objects actually look like is hard. And the other point is that since it's a normal function, if you mistype or if you do it wrong, it will just not see this as a constructor. And in this case, well, you forgot to write new there, which means that you just invoked the function. And since this.x just accesses the global this, you just created new global variables x and y. And in short, there is no real structure in JavaScript programs. You can kind of simulate it by having conventions and by using special patterns, but there is no real structure in JavaScript programs. And that's not only hard for humans, it's also hard for tools. So just minifying a program that in JavaScript that is guaranteed to work is hard, because it's almost impossible to find every instantiation class, hidden class. So it's hard. Yeah, so you get 2 new variables here. This is one of the JavaScript's philosophies, or at least it was. You just keep trucking. Everything works. It will just do something. You don't know exactly what most of the time, but it will continue running. And yeah, we don't really like that. In this example, for instance, there is a bug. I'll give you a few seconds to try to find out where it is. I mean, there's a hint in the title. But, well, it turns out that even though onReadyState change is written in lowercase, the readyState here has to be written with an S in capital. If you don't do that, you will just get undefined back, which is then coerced to 0, which is then equals 4. It's not, so it's just going to work. And these kind of things are annoying. The other thing is another example is the automatic conversions, implicit conversions, in this case boxing. When you take a string and you assign a property to that string, it will silently do that, but even in the next line it will not be there anymore. That's because the moment you have used the dot, it will box the string, and then it will just discard the box, and then if you try to do it again, well, you get a new box, and that new box will not have the hash assigned to it. Another example that is kind of classic is the implicit conversions that just go through all kinds of different types. You can compare a string to a double and then to a Boolean and then to another value, and eventually you might end up with 2.0 equals 1. Well, transitively. So, but enough about JavaScript. Let's show some of the Dart features. In this case, I will show some how you build web applications. We have several libraries. In this case, the HTML library, which is a refactored which is a better DOM, let's say that way. So the HTML team took the DOM library and wrote Dart::HTML on top of it, improving on the existing API. Then we also have the pub infrastructure, which is like NPM on Node or Ruby Gems. It's basically one centralized place where you can get libraries and packages from. And those two together makes it easy to write relatively big applications without too much effort. And now I will show you another demo of that. So I don't have internet here, so the application, but you can get this application that I'm loading from StageXL's demo page, GitHub. So there are a few different samples here, and I'm going to run this example here. Let's just run it so that you have an idea of what it's actually doing. So this is just a small example to showcasing StageXL. StageXL is written by Bernhard Pichler, and he's trying to write a library that is familiar to Flash developers. So basically, he comes from Flash. He found that Dart and Flash and ActionScript are could fit and wrote a library that simulates or that gives Flash developers something familiar. And this demo is showing off the, what was it? We will see. So let's just, so, no. So it's showing off the juggler tween. So the program itself is relatively small. It just imports math and HTML. So HTML is the way to access the DOM, and then it imports the package. So this is where pub came in. You told the Dart editor, or you have a specific file where you say, I want to get from pub stage XL. It will fetch it for you, and then I can't demonstrate because I don't have internet here. And then you just import the package using the special package import syntax. And just doing that allows you to write the application that you just saw in 40 lines. And it's not even complicated lines. So you have a few global variables here. Then you have the main. Every application in Dart starts with the main. Nothing is executed outside the main. And that even means that these globals, even though they look like they will do something, they are initialized lazily. Nothing happens outside main. And so this program starts by instantiating a new render loop, adding a stage, that's all Flash-like thing is, loading an image, and then starting the animation. And this animation then uses the bitmap data to create a real bitmap and initializing some properties. So this dot dot is just a way to avoid the return value of the dot dot will be the object on which you applied the operations. In this case, even though you write new bitmap dot pivot x, after the dot dot, it will still be the new bitmap. So you're basically just doing dot dot dots on the bitmap. You could have also just written logo bitmap dot pivot x equals something, logo bitmap dot pivot y equals something, and so on. It's just a shorthand for avoiding these repetitive variable uses. It's called a cascading something. Anyways. And then it uses a juggler to animate. So this is the animation that brings the logo into front, and this is the animation that brings the logo back in the back. One thing I forgot to say is this then here. Most of the Dart libraries are asynchronous, and from the start on we used promises, which we call futures, and they are completely integrated into the language. All I/O, all HTML, everything uses promises or strings if there can be more of them. So in this case, basically it says load this picture, and only one. So once it's loaded, which can take some time, then do something with that picture. So one thing I want to show too is that we have a really nice debugging support, so you can breakpoint while the Dartium was still running. So this is Chrome with a Dart VM. So this is not the real Chrome. This is a special Chrome that has already Dart VM included, and that means that the integration with the editor is quite nice. It has breakpoints that go from the editor to the running Dartium, and now I can just step through the application and set breakpoints, run. Yeah, you have. Oh yes, you can see local variables here. You have a. It's hard. You have a bitmap data, and you have a bitmap, and you can manipulate. You can even execute some expressions there. So this basically shows the nice breakpoint and debugging facilities. But, so let's stop that one. We also can compile to JavaScript, and I haven't tried that, so this might fail. And it's JavaScript, so now it's compiling it to JavaScript. And oh, it's running it in Firefox. That's actually not too bad. So it's compiling to JavaScript and then just, Firefox, I don't know which version, and then just runs it in the browser. And we support basically all major web browsers, starting with IE9 at the moment. It's pretty much following the Google's recommendations, the Google standards, at least the last 2 versions of every browser. And it's my job to make sure that this actually works. Yes. So what are the benefits of the web application? I didn't show that, but you don't need to compile to run your application. So you can just press F5 and it will run the new source, at least in Dartium. If you compile to JavaScript, of course, you need to take the compilation step into account. But during development, you just write your code, you run Dartium, you press F5, you change your code, you press F5, and it's there. And that's basically how we develop web applications with Dart. So even though the Dart to JavaScript compilation takes a little bit of time, you only do that from time to time to make sure that your app still works in other browsers or in Chrome. There's this integrated debugging experience, which I showed the breakpoints at least, and the variables. I showed that it works in Firefox by accident, but still. I mean, I showed it by accident. And there's a rich ecosystem of pub packages. So StageXL is just one of many, and we get new packages all the time. Of course, there are some that are smaller than others, but there are some nice packages out there. So now compiling to JavaScript, which is my job at the moment. So we want to have small code, fast code, and we want to retain the semantics. So it's relatively easy to just say, well, you wrote it's an integer here, so I will just assume it's an integer and compile it to JavaScript. And if you got it wrong, well, then it will just do anything that JavaScript did before. We don't want that. So when we compile the JavaScript, we want to make sure that the semantics that you expect, like not assigning and not accessing properties that don't exist or things like that you actually get them. And that means that there's a little bit of work to do. So also we want it to be fast, and that means an optimizing compiler. An optimizing compiler in this case means it has function inlining, loop invariant code motion, the global value numbering, type propagation, redundant load elimination, dead code elimination, global type inference, and much, much, much more there. So we have a bunch of optimizations that need to run to make efficient code. So this is now a first example how we compile Dart to JavaScript. It's pretty much what I had before. And in this case, there's a really nice equivalent compilation. We just compile from one side to the other. It looks the same. It works more or less the same. I mean, no, it works. It looks more or less the same. And it works the same. And there's just one thing that is maybe interesting to you. We encode the arity into the method names. So that means if you do not provide enough arguments, or if you provide too many, you will get an error. Whereas in JavaScript, if you forget one or if you add one too many, it will just silently either put an undefined in place or ignore it. And by having this convention on the method name, we make sure we don't need to test the length argument of function. Yes, one of the things that is important when you use pub packages is that they can be bigger, and they might not be tuned for your purpose. So they might contain classes that you never want to use. Yes, they can be bigger. And that's okay, because we from the beginning on said we can and we want to do tree shaking, which basically means that we do not want to include everything. And here's an example. So we have main, bash, and foo, 3 functions in one file. Main calls foo calls then an imported bar, and in the library that we imported, there's also a boo, but it's not called. So after Dart to JavaScript, you end up with only those 3 methods. You're not going to compile bars, and you're not going to compile boo. We actually see that you never called them, and therefore we don't need to add them. We don't need to put them into the JavaScript output. So this means that if your package contains different ways of of doing things like StageXL, for instance, has many different classes to emulate the Flash APIs. Well, if you don't use all of them, you won't get a huge JavaScript output because the tree shaker will get rid of them. We do this in 2 levels, just for those that are a little bit interested in compilations. We start by reading the file and running through it in a fast way without actually understanding every method. We're just looking for what are the classes, what are the methods, but not the bodies. That's the diet parser. Then we run another resolution where we find out what the variables are, what they're pointing to, but this time still just looking at the body. So there's a return, there's a call to foo, so we assume there's a foo that needs to be included. And then at that moment we also parse the methods that can be reached. And then the third step, when we compile the methods and optimize them, when we do dead code elimination, at that point we really shrink down to what we think is necessary. So if there's a dead code elimination that eliminates a call to foo, well, then we will not include that foo, even though before we thought potentially that it was necessary. And yes, and the last step is then emission of the JavaScript sources. Again, for those interested in compilers, the intermediate representations of Dart to JavaScript. We start out with a Dart syntax tree, so this is just standard ASTs. Then we go through a builder where we build SSA nodes. They are single assignment instructions, and we optimize them, and in the end we create a JavaScript AST, and then we take that JavaScript AST and we produce either minified or non-minified JavaScript. So a little bit more about the optimizations on an example. So Delta Blue is one of the Octane benchmarks. It's a constraint solving algorithm. What that means is that it takes different constraints and tries to satisfy them. If you take a web page, for instance, you have elements on them and you have constraints on them. For instance, a div or the span here needs to have a specific, at least a specific margin. This one has to have something else. And putting all those on the page and resolving all the constraints, that's what basically Delta Blue does. I mean, we don't use Delta Blue in Chrome, but this is what this benchmark does. Here's one of those methods inside the Delta Blue benchmark. It's not really important what it does, but it's a 5-line function. It just runs through all the constraints, tries to look at some properties, and then adds them to some other list. So when we compile it, so yes, I forgot to say that in Dart the types are optional, and they don't have any. So the type annotations are optional, and they don't have any meaning if you do not run in checked mode. That is, neither the VM nor Dart to JavaScript need types, and if you add types and they're correct, they will not influence the behavior. So if you write int x, it will be exactly the same as if you wrote var x, which means that int x will be initialized to null, for instance. More important in this case, as an example, you can always just take an example with types, remove all the types, and it will have the same behavior. Yes, so if you take this example without types and compile it without any optimizations, you will get this JavaScript, which is simple, not good enough. I mean, this is way too long. There are interceptors in there. Nobody knows. We know what they do, but they just bloated code. And we can do better. And there are a few things that we do. We start by the number checks. So in this case, we don't know what the length is of T2, which was, we can check that. T2 is the interceptor of T1, which was the constraints. So we don't know that length is a number, and we want to compare it against the number, but since we only allowed to compare numbers with numbers, one of the semantics that we say this is the non-surprising semantics, we need to check that it is a number. And that means that instead of having one nice line, you have 3. And so the challenge that we in Dart to JavaScript have is how can we write clean how can we have clean semantics and unsurprising behavior without all those extra checks when we compile the JavaScript? And in order to do that, we need to do global optimizations. And good thing for us is that Dart is structured, so we know where classes are, we know what fields every class has, we know how variables are resolved, so we can do global optimizations. And as I showed, not only does this type annotation, this structure allow you to have completions in the editor or warnings in the editor, it also allows us to do the global type optimizations that are necessary to produce nice JavaScript. So to give you an example how one of these global optimizations in basically the type inference that is necessary, that is really crucial for this benchmark, how this works is look at these three methods. We have main, foo, and bar. And its main just calls foo calls bar, and bar then calls foo again, depending. And I can show you this here. So foo is called with an integer. Then bar is called with that integer, since we just called it with an integer. And however, then foo is also called with a string. And then foo calls back with a string bar. So if you now look at the types, and then we print it. So if you now look at the types, what we infer is that foo is called either with int or string, bar is called either with int or string, and yes, and that's what we need. With this information, we can do, if we apply this global type inference to our bigger applications, in this case the benchmark, we can get much better, and I will show that now. So with global type inference, when it runs, it tells us that v is either null or a variable. So exact means that it knows it's this type, this class, and it also gives us the type for call, which is an array of constraints. And that means that we can then look at where v is used and use that to get the types from those member calls. So we have somewhere else inferred that the v.determined by is either null or constraints, and v constraints length, for instance, is always an int. And using these information that also have been done on the outside, we can start optimizing. So we start out with this 526 characters method that we had initially when we didn't optimize. And now we start optimizing. So we know that v is either a null or an except variable. So we also know that v has a field that is called determined by. So instead of calling through a getter to make sure that this field actually exists, we just use that field now. If it's null, it will still throw a null pointer exception. You cannot access a field of null in. So that works. We also know that v.constraints returns us an array of constraints. So we can now use that to directly access the fields there. So just to show you, instead of going through the length getters and index getters, we just access it directly. Similarly, we have inferred that the constraints length always returns an integer. That means we do not need to check if it's a number anymore. So we can just use it directly in the comparison. And now that we know that now that this whole program has become simpler, we can also remove this while true loop and replace it with a nice while loop, or for loop in this case. And we are now already a third of the original JavaScript output that was unoptimized. But there's even more to do. So if you look now at call, we know that this is an array of constraints too. So instead of going through the add method that we have added on the side, so we never really changed the prototypes of existing JavaScript objects. So we add from the side. In this case, we use an interceptor. But since we know that it's a JavaScript array, we can directly call push. So we don't need to go through some intercepting things. And we can also just push the initialization of this variable inside the loop, and 41% smaller than the original. And we can continue. We have inferred that subclass is a constraint and it cannot be null, so we don't need to check for null. So that one is gone too. And there is a, yes, we also know that satisfied always returns a Boolean. That one's gone. And now we're at 50% of the original JavaScript output. And now if you look at the fully optimized JavaScript, it really looks reasonable. I mean, there's still some $2s here and there, and $0 is satisfied $0, but all in all, this almost looks like it could have been written by hand in JavaScript. And these optimizations, they really pay off. If you look at the performance graph of this benchmark, the blue line is the Dart VM, so that one at some point in 2012 just overtook V8. I have to specify what V8 is. In this case, V8 is the Octane benchmark. So this is basically the same benchmark handwritten in JavaScript. We took that benchmark, wrote it in Dart, and then ran them in parallel, basically. So in 2012, the Dart VM overtook V8 on that benchmark, and is still far ahead. And more interestingly, for Dart to JavaScript here, is that in the middle of early 2013, it became also faster than V8. And that's kind of interesting, because we only compile the JavaScript. So in some sense, we should never be faster than the JavaScript version. The reason that happens is that for most of the things, we really get very close to what handwritten JavaScript is. And for some cases, we can do better. We can do inlining. We know that some finals can't change, and therefore we don't need to. We can assume some properties and work on them. All in all, it means that the JavaScript code that we produce is more optimized than the handwritten JavaScript code of that benchmark, and therefore we are still slightly faster. That's not true for every benchmark, but there are some benchmarks where Dart to JavaScript does better, and all in all, our goal is to be as fast as handwritten JavaScript. So, some conclusions. So, Dart is unsurprising. We removed all those vets from JavaScript. It's object-oriented, well, reasonable, familiar, productive. It's open source. Open source is important to us. We develop completely in the open, and it's ready to be used. So we had a V1 release last October, I think, and we are not changing the API anymore. We're not changing the libraries, the language spec anymore. You can use it, and you should be. It's stable now. So we just go to dartlang.org, download the editor. There are lots of samples on that page. You can try it. There's a nice code lab that guides you through creating a pirate badge. Try it out. And that's it. Thank you. Any questions? I shouldn't have said that. I have even these flight thingies for good questions. No? Yes?
Is there any way to test your Dart code?
Unit test, you mean?
Yeah.
Yes. So there is a unit test. There's a unit test library package that works nicely, but it's not integrated into the language. So basically, it's like any other unit testing framework. You use one and you comply with you follow the APIs. We have annotations that helps finding maybe some that makes some unit testing frameworks possible, but I think the one that we use doesn't use them. So you just follow a specific pattern and then you say test it. And yeah. Yes.
Is there any way to use the existing third-party JavaScript library?
I think it would have. Yes, there's a Dart::JS library. It's interesting because since we want the VM and JavaScript since they need to run in the same browser and they need to run when you develop with Dartium, you need to separate the two heaps, so the two memories, and that means that it's not like in Quit where you could just tweak and just get to JavaScript and do something fancy within a function, but it's more of you have a separated protocol. How do you talk to the others? There are proxies in place to make sure that when you invoke a proxy, it goes down to the other side and executes it there. So there's a little bit of overhead, but it also means that you have a nice clean separation, and and it works as well in Dartium as in Dart to JavaScript. Yes?
How much will I miss if I just were to not use Eclipse IDE? And what
Yes.
benefits for them?
The Dart editor is definitely the tool that we use most. In my opinion, it is quite nice because it has the code completion and the warnings and everything included, but you don't need to. Many of the Dart developers themselves work with Emacs or VI or Sublime. They just got used to it and can't switch anymore. You have an analyzer that is, you run a tool outside your editor, and you find warnings this way. You might not have them immediately. We have syntax files for Sublime, VI, and Emacs, so you can code in them reasonably. And there is currently an effort in the Dart editor team to move towards a more server client-based architecture where you end up with a server running that analyzes your code, and the editor is just using that to show your information, to refactor and so on. And once that's done, we hope that other editors like Sublime or Emacs or maybe even VI can then use that to directly have semantic coloring and refactorings and warnings.
Could I kind of run a separate VM, or would that be all in the browser?
I'm not sure I understand that question.
I'm writing Dart code in Emacs.
Yes.
I want to try it out by saying.
Okay. Yeah. So I didn't say that, but the Dart VM can be run standalone, so without a browser. And we have a nice library that is Dart.io that is only available in the standalone browser, where you get node-like behavior. So we have a nice we have spent some time and resources on getting something that is competing with Node in some sense. Yes, I'm running out of these things. So. SM.js. This question comes up a lot, but it's not helping at all. SM.js is not helping at all. The main problem with SM.js is that it's too low level. So you can nicely compile C into it, but the moment you have, so you would kind of need to take the full virtual machine, the Dart virtual machine, compile it to SM.js, and even then you probably run into issues because some things are not there, and you end up with a huge thing. So it's really not useful. I mean, maybe you could do some tech demonstration that you can run a virtual machine, but it's not really useful. And for Dart to JavaScript, it's almost impossible. So just garbage collection doesn't exist in SM.js. So at that point already, you have to give up. You could decide that some of the functions where you inferred that all inputs are integers, and you do some mathematically things, you could decide to write SM.js for those, if you really think so. But V8, for instance, shows that you don't need that. If you use nice instructions that are recognized in some sense by V8 or by JavaScript engines, they optimize them anyway. They are pretty good at that. So we don't think there is any advantage in using SM.js. Yes?
So you said that removing types is not a case.
Yes.
What if I specify type that's wrong, like in the case where you infer that was imported, and I specify my type that what was the wrong, when was the wrong?
So I will start repeating the questions since it's recorded. And so what happens if you write the wrong types? Since I said that types never have an influence on the program. The VM in production mode completely ignores the types, a type annotation. So if we have generic types of lists, and there the types do have an impact because a list of int becomes a list of int. You can test it. But if you just write int x equals something, the VM in production mode just ignores it completely. That's because it's faster. And most of the time you can't do anything on the client once it's running anyway. When you develop, however, you run in checked mode. So you develop in checked mode where every annotation that you write is checked. And if it's wrong, you get a type assertion that tells you something is wrong. So in one mode, they don't have any effect at all. And in development, they are very, very helpful. So Yes.
You mentioned that type notations are helpful. And you basically have rules and errors like that. But you get any references for you to this by adding more types?
Good question. And, I will use one of those Angular patches. So the question is, the type annotations are optional. So do they have an effect on optimization or something similar? So the VM, no. The VM completely ignores them, will never do anything with them. At some point, Data JavaScript used them to optimistically assume that you will probably, it's probably that, so I will optimize more in that direction, even though I will still check. And even that has gone, so at the moment, as far as I know, the type annotations, if you run in non-checked mode, don't have any effect at all. And in the case of the VM, checking is costing more than taking advantage of the types that you know. Maybe you could get better if you did a little bit more of whole program analysis, or if you really tune towards it. But at the moment, it's definitely faster if you run without type checking than with. And they don't want to rely on the types. Most of the time, they get them anyway. So the VM runs your program for several cycles, records what type were used, and then optimizes for those. It will still check them to make sure that they haven't changed, but it will optimize for them. So it already gets the types, and they're frequently more precise than what you write. So if you write list, which is our array, x equals something, that could be any list. That could be your own list. That could be the internal typed array list. That could be the normal list. So you usually don't express that. Whereas the VM will record, you use the typed array list here, I will optimize for that, and I will just check that it's the same the next time. So therefore, it's not really helpful. Good. I think we will take a small break, and then Slava will continue with Angular. Thank you.